Hello, today we'll see pattern matching with record patterns and Paris monuments. It is quite longer than usual for this video. So, in Java, record patterns allow you to check if an object is an instance of a record, and if so, automatically extract its component values for further use. This is especially useful when you work with structured data. For more background, you can refer to JEP 440. Let's discover it with an example using famous Paris monuments. Simple record pattern example. Imagine we define a record monument like this record monument with a string name and int year built. Now we want to print a message if the object is a monument. Using record patterns, we can extract the name and year directly. For example, in the method static void print monument info, taking an object and as body if obj instance of monument parenthesis string name comma int year close parenthesis system.out.println name plus was built in plus year. So if we pass a monument like the Eiffel Tower, it will print Eiffel Tower was built in 1889. Notice that a null will never match a record pattern, so no worries about a null pointer exception. Next, using a type pattern instead. You could also do it in a slightly different way by first capturing the monument, then calling its method. For example, in this method, static void print monument info type pattern, taking an object, obj, and its body is if obj instance of monument m. You see there isn't the field of the record, and in the if you have system.out.println m.name. You call the accessor for the name was built in plus m.yearBuilt. You call the accessor for the year built. You see this is a bit different than this, and in the second part we do not have that part. Next, working with generic records. Suppose you have a generic record, like a box containing a monument. A box, understand it like a gift box when the street sellers see some monument in a little box to offer to your family, etc. Record box, angle bracket T, the generic, close angle bracket, and as parameter T content. So this is a record with a generic. You can pattern match a specific type inside the box. For example, in the method static void print box monument, parenthesis box, angle bracket string, close angle bracket box for the record with generic. And as the body of the method, we have if box instance of box, angle bracket string, close angle bracket, parenthesis string monument name, close parenthesis. Then the if leads to system.out.println box contains plus monument name. And you get the monument name that is extracted from this record with generic. But, important, you must avoid unsafe cast. If you try to pattern match on a box without a grounded type, it won't compile. Example of wrong code, static void wrong code, wrong box match, taking a box without the definition of the type of the generic, you will have an error. Box cannot be safely cast to box angle bracket string close angle bracket, because the if checks box instance of box angle bracket string close angle bracket with the name etc. And this can be cast to this. It is not the same. You see. Next, type inference with var. You don't always need to repeat the types. Java can infer them for you with var. For example, static void print monument info var, taking an object obj, and in the body of the method, if obj instance of monument with var name and var year. You see, this is the change. We do not put, for example, string and int, system.out.println name plus was built in plus year. It is inferred automatically. It is shorter and cleaner. Next, nested record patterns Paris in layers. You can even nest record patterns when working with more complex structures. Imagine you have an enum style with a modern historic, record location with latitude and longitude, a record style monument taking the two previous, the location and the style, and above this, an area taking two monuments for an area to see. For example, you are in this area of Paris and it is split in north-south, and you define the main monument in each of these subparts. So here, taking a style monument north and a style monument south. Now let's print the latitude of the northern monument. So here you have the method static print north latitude area for the parameter, and in the body of the method we have if area instance of area. Here we define the record, the nested record, to be able to extract then the content of its fields. For example, area parenthesis style monument parenthesis location, and here var lat for latitude, comma var lon for longitude, comma var style, the second parameter of a style monument, and then we put a var source monument because we do not define it more on this because it is not the part that interests us. So, and then we put system.out.println latitude of northern monument plus lat, which is here, which is extracted from this syntax. Example, if north represents the Arc de Triomphe and south the Louvre Museum, the program will print the arc's latitude. So here we would have Arc de Triomphe with its latitude, and this method will print the latitude of Arc de Triomphe. Okay, so next, nested generic example. You can nest pattern with generic types too. Example, here in the method static void nested box example, we take as a parameter of the method box angle bracket string close angle bracket box, and as a body if box instance of box parenthesis var monument name, you close the parenthesis, system.out.println inner box contains monument name. So you see, you can put a nested box inside another box, and you can still extract the information from this syntax. Here, even though you have a box inside a box, Java infers everything. Summary. With record patterns and type inference, Java makes it easier to work with structured data. Whether you're describing points on a map or historic Paris monuments, you can check and extract values in one line, avoid verbose code, and safely navigate nested structures. Thank you very much, and maybe see you in another video. Bye!